Today we're going to run a little 6,000 volt 3000 amp surge test on this light bulb circuit and a very popular internationally known surge suppressor, Phoenix Contact, to see what type of positive benefit it'll have on protecting electrical equipment, but also consider the electronic equipment that is downstream. Suppressor is installed in parallel to the lighting circuit. Generator is charging to 6,000 volts to be released into the peak of the sine wave. Wow! Imagine if that was your electronic equipment connected to this surge suppressor. Not too much protection at all. Let's change the light bulb and insert a sine tamer unit. Now we very carefully replaced the light bulb, considering all the broken glass, and inserted the sine tamer suppressor into the circuit. An LAST120 3Y2, just like the previous Phoenix Contact unit. Generator charging. Release the surge. No impact on the bulb whatsoever. Let's do this test one more time. And in fact, we could continue to do it for multiple times, but just for the sake of, you can see it happen here, let's charge it again. Release the surge. And again, just a flicker. Now you can see the benefit of having the sine tamer suppressor with its lower residual let-through voltage rating to absolutely provide complete protection for electrical and electronic equipment.
Fox cameraman moved out of the way and into safe positions, and some shots of these lightning bolts were scary stuff. And that happened right near the 18th green again. Our lock cameras caught that bolt, and let me just tell you, it wasn't too far from our booth. That is a live look at the tree, and it was shook. That's all the way down.
Love like you know what it means. And it can't be wrong. Take my heart and make it strong. You're simply the best. Better than all the rest. Better than anyone. Anyone I've ever met. I'm stuck on your heart. I hang on every word you say. Tear us apart. Baby, I would rather be dead. In your heart, see the start of every night and every day. In your eyes, I get lost, I get washed away.
Today we're going to run a little 6,000 volt 3000 amp surge test on this light bulb circuit and a very popular internationally known surge suppressor, Phoenix Contact, to see what type of positive benefit it'll have on protecting electrical equipment, but also consider the electronic equipment that is downstream. Suppressor is installed in parallel to the lighting circuit. Generator is charging to 6,000 volts to be released into the peak of the sine wave. Wow! Imagine if that was your electronic equipment connected to this surge suppressor. Not too much protection at all. Let's change the light bulb and insert a sine tamer unit. Now we very carefully replaced the light bulb, considering all the broken glass, and inserted the Sontamer suppressor into the circuit. An LAST 120 3Y2, just like the previous Phoenix contact unit. Generator charging. Release the surge. No impact on the bulb whatsoever. Let's do this test one more time. And in fact, we could continue to do it for multiple times, but just for the sake of, you can see it happen here, let's charge it again. Release the surge. And again, just a flicker. Now you can see the benefit of having the Sontamer suppressor with its lower residual let-through voltage rating to absolutely provide complete protection for your electrical and electronic equipment.
Fox cameraman moved out of the way and into safe positions, and some shots of these lightning bolts were scary stuff. And that happened right near the 18th green. Again, our lock cameras caught that bolt. And let me just tell you, it wasn't too far from our booth. That is a live look at the tree. And it was shook. That's all the way down.
Love like you know what it means. And it can't be wrong. Take my heart and make it strong. You're simply the best. Better than all the rest. Better than anyone. Anyone I've ever met. I'm stuck on your heart. I hang on every word you say. Tear us apart. Baby, I would rather be dead. In your heart, see the start of every night and every day. In your eyes, I get lost, I get washed away.
Okay, today we're going to run a little 6,000 volt 3,000 amp surge test on this light bulb circuit and a very popular internationally known surge suppressor, Phoenix Contact, to see what type of positive benefit it'll have on protecting electrical equipment, but also consider the electronic equipment that is downstream. Suppressor is installed in parallel to the lighting circuit. Generator is charging to 6,000 volts to be released into the
We are about 20 minutes behind. So in this conference, I want to just first of all thank all of you for, it was a short and quick notice to invite you all to come and join us in this unique niche. And what this conference is about is to let us understand that is a solution that can help us maximize the electric power that we already have available. Now what this particular event is not about is generation of power. I know that everybody wants more power. We want to go green. We want more megawatts. But nobody talks about the one that is available. How can we maximize it? And that's what we have come to do. So this is going to be a full power quality suite. And I would appeal to you to open up, listen, raise your questions. And for those online, if you have questions, feel free to put it in the chat. We have people monitoring to make sure that we answer your questions that are very critical. And very important that you put it in the chat. And then if anyone asking questions from Enugu or from Lagos on site, we'll be able to project the person and then you can see who is asking the question and get responses. Asperon says is a power quality company. Solutions you can think of in power quality. In our bucket list today we have TSI Power. TSI Power is the #1 power quality company in the world. When it comes to voltage and line conditioners, we have in our bucket list in the program Energy Control Systems, Syntema, which is the #1 surge protection device in the world. And we have other solutions that you're going to listen to from our very experienced seasoned speakers from around the world. It's very much interesting that I will introduce to you that we have support desk in Singapore, we have support desk in India, we have support desk in the US, we have at home here in Nigeria. And on site today, right after the lunch, when we'll be discussing the Syntema, we have somebody that flew in from South Africa who is the MD of Energy Control Systems in Africa, Jim Rosa. He will be speaking to us here. Our first speaker will be Nam Peik. Nam is seated in the US and he will be speaking to us from there. We have audience from Tanzania, and I want to thank you for spending almost 1 hour or 2 waiting for us to kick off. The time was set for 10:30 a.m. GMT +1, which is GMT +3 in Tanzania. So I appeal to you that if you felt we started late, it's just that we read the time zone a little bit wrongly. Thank you very much. We have a lot of guests coming in this room, and I will quickly take 1 second to introduce those who are in the room, while the rest will come, and then we'll do that behind as we proceed. Permit me to take 1 minute to go around the room quickly. 1 minute, Mr. George, Mantrak. All right. Tony, okay. And I have in this room Lambert Electronic. Lambert represented. And Idea Solutions. Somebody from Idea Solutions. Okay, very good. And yes, these are my people, wonderful people. So I want to thank you. And what's coming again? No, say it.
Lumic Prestige Energies.
Okay, perfect. P-Man? Oh, P1. Okay, perfect. Good to have you guys. We'll kick off right away because our time is already clicking. I would hand over the console to Enugu. Can we get Enugu quickly? Okay, is that Enugu right there? Enugu there? Just to let you know, we have the same setting in Enugu. We have people in Oakland Hotel in Enugu. Okay, maybe we'll have to take the Enugu introduction a little bit later. We're going to swing in. Are you able to get them? You're not able to get Enugu? Okay, as soon as they're ready, let me know, but we're going to swing in straight up into this conference. And that team MTN mentioned they were going to be here. We had ATC and IHS signed up. I know for traffic's sake they're not here, or maybe the Nigerian thing, African time. Unfortunately, we will not wait. So one of the highlights of this event is we will take it a little bit later. I'll be interjecting from time to time how we can maximize the available electric power using power quality. See, you find that you'll be consuming a lot of power or probably see yourself out of the grid. You're no longer on the grid because you can't control the power quality. Your very expensive machines are blowing up. The voltage is not enough to power the machines. You hit a lot of phase losses, neutral loss from power holding. Nigeria is power holding. I know Tanzania is TANESCO. Senegal, if you're online, I know that is Senelec or something. So it's not enough. If we can arrest the number of hours of available power and clean it up, which is what we do, so you can use it without spending money on running your diesel generators, we're going to put that whole revenue back in your pocket. Plus, we're going to have the cost of maintenance almost chopped to zero. Why are we so confident? We've proven these things the world over. For example, I told my MTN people, they're going to be here. If we pick up a 30 kVA generator running on 50%, running on 50% load over 7 hours for 1,000 sites, we'll be hitting about $11 million in revenue back in the pocket of the operators. Guaranteed. How we will do that is what you will find out from the solutions we're going to present. So I want you to cheer up, open up your mind. We're going to be talking a number of top quality products made in the United States, designed in the US, but that's not the catch. The catch is that these solutions are totally proven in Africa, in many places in Africa and around the world. So, if you have questions in the room, when it's going on, you can indicate, we will be able to take all that. If you have questions in Tanzania, like we said, put it in the chat, we'll be able to address that. And as soon as Enugu comes online, please let us know so we can welcome them to this event. Let's hit the road running. Can we have, we're going to hand over to Nampeg. Nam, can we go to the Zoom? Nam will be taking up the first presentation, which is going to be talking about the TSI powered VRP. The VRP is the #1 static voltage regulator in the world. It's used by US Air Force, Navy, top government critical, mission critical facilities. And now we'll be presenting on the VRP today as part of the fleet that we have for you. So relax, we're going to have about 4 hours with you today. Don't be in a hurry to go. Thank you very much. And don't sleep off. If the AC is too much in the room, let us know, we'll tone it down. All right. Everybody cheer up. Fasten your seatbelt and let's get rolling. Now over to you.
Hello, can you hear me?
Yes, we can hear you.
Great. And can you see my presentation too?
Uh,
Is
no, you
it-
can
is
share
it
the
up?
screen.
My screen?
Yeah, share your screen.
Hello?
Yeah, try to share your screen one more time.
Okay. You see my screen now? Hello?
Yeah, I see your presentation now.
Do you see it now?
Yes. So you
Wonderful.
can make it.
Can I get started?
You can make it full screen.
Let's see. I'm trying to see. Is it better? Hello?
Yes. Yes.
Are you getting the full screen now?
Exactly. Go ahead.
Okay, welcome to the Power Quality Conference 2025 in Lagos, Nigeria. I am Nam Paik, VP of Sales at TSI Power Corporation. I've been with this company for 26 years, from get-go when it got started. Electrical engineer myself, designed several products. But now I'm doing mostly sales and marketing worldwide. And Tim, I'm working very closely with Tim to reintroduce our products to Africa. We were introduced to Africa many years ago, about 20 years ago, starting with MTN Uganda. And I'll mention some of that in my presentation later. Anyway, I'm going to next page. Okay, TSI Power is an American manufacturer started in 1998. Our headquarters is shown on the picture on the right. We design, manufacture a full suite of industrial and telecom grade power protection and backup products. Our products have been installed and proven globally in various industries, and they protect all sensitive electronic equipment from all kinds of power quality problems. TSI Power India was established about 13 years ago, and large factory there in India, and we were started to serve the Asian and African markets. And you can see the manufacturing plant at the bottom right. Okay, next page. This is our entire product portfolio that we make in the USA. In India, currently, only the VRP products are made. But in USA, we build everything else that you see on the screen here. And I've put some nice power quality problems above. When you have voltage swing, especially voltage swell or over voltage conditions, it can damage equipment and equipment can shut down, and circuit breakers can trip. It's very bad. So the VRP will protect you against that. VRP will also protect against brownouts and undervoltages as well as some voltage sags. The next product here, I won't mention it too much. This is just a large three-phase voltage regulator going up to about a megawatt, Falcon voltage stabilizer. And then we have a Sparrowhawk sag protector. It can take a sag of minus 50% for 7 seconds. And it has a lot of capacitors inside, and we generate AC power to fill in what's missing during those 7 seconds using this voltage Sparrowhawk product. And then we make automatic transfer switches, nothing big, just compact single phase units, 120 volts and 230 volts, single phase only, going up to 15 to 40 amps only. And then XUPS, the outdoor UPS product. I'll mention some of that covered later, but I want to spend primarily the VRP, spend 90% of the time presenting the VRP technology and products, because I believe this is what really will be very, very useful and have proven to be very useful for over 20 years in many, many countries in Africa, including Nigeria. Okay, next page. This is the VRP technology in a nutshell. It's a revolutionary new technology that was developed about 25 years ago, perfected about 20 years ago. It took about 5 years for us to go through all kinds of troubles and problems during the first 5 years of its manufacturing and installation around the world. So that's how difficult this technology is to master. Basically, it works this way. You got incoming AC. This could swing, say, from 230 volts plus minus 20 or 25% in some countries, in some locations. It could also contain some surges and spikes and noise. So we first take it into our surge protector, an AC filter, primarily to protect ourselves, as well as connected equipment from surges and spikes. Sine tamer would go before this. It'll take care of all the big lightnings. You've probably seen some videos several times already of how lightning strike could damage equipment. And sine tamer surge protector will provide remnant voltage of like 400 or 500 volts, which we can handle without any problems. So then, it's protected and cleaned AC power, but voltage is still bad here. So we go through a buck boost transformer. This is a little isolation transformer with 20% capacity of full output power. For example, if the load was 10 kVA total, we would only use a 2 kVA buck boost transformer. We could still add 20% or subtract 20% from the voltage with this technology. What we do is we take some of this power, up to 20% of the incoming power, and use an AC to AC chopper converter with a microprocessor control. It happens at about 20 kilohertz, similar to switching frequency as your switch mode power supplies. You know, your switch mode power supply drastically reduced the size of power supplies. I know some of you who are in the 60s, who started in the 70s or 80s, had linear power supplies, which is humongous. 1 kilowatt linear power supply used to weigh like 50 kilograms. But now with the switch mode power supply, a 1 kilowatt power supply could only weigh about maybe 1 or 2 kilograms. So there's been like a 30 to 1, maybe 20 to 1 reduction in size and weight using high frequency technology, and that's what we do. Yeah. So once we have regulated voltage coming out of this buck boost transformer, and we do this on a half cycle by half cycle or cycle by cycle basis. so that no voltage, we detect one cycle of AC, which is 20 milliseconds. Microprocessor sees it and feeds it back and says, okay, the previous cycle, one cycle had a minus 20%. So let's add 20%. So on the 20 milliseconds later, correct waveform goes out. And this happens 50 or 60 times every second. And that's the power of the microprocessor control, of course. And then we go through the AC filter one more time, and then we connect it to load equipment here. We use high-frequency IGBT technology, and microprocessor measures it against reference voltage, adds or subtracts voltage to achieve precisely regulated 120, 208, 230, 240, or 277 volt output. Output voltage correction time is 20 milliseconds or less. It doesn't show here, but there's a automatic bypass switch built in, automatic. In case of any problems, a blown fuse or something like that in this circuit, it will bypass automatically to incoming AC power. So at least you get the surge protection and filtering, but you don't get the voltage regulation. And a red LED will flash saying that voltage regulation is not there. The green regulation AC LED will extinguish. That's how you tell. Okay, this is the technology that I described. Okay, here's what VRP looks like. This one is a typical single-phase unit. We build single-phase from about 1.5 kilowatts all the way up to about 15 kilowatts. Single-phase. Then three-phase, we started about 9 kilowatts. And in case of 230/400 volt three-phase Y input, can take it up to 300 kilowatts in its largest cabinet. Okay, this is what it looks like. When we pop open the cover, this is what you will see from the top. This is the buck-boost transformer. This is the control board with the microprocessor and the IGBT inverter system, AC to AC conversion stage, operating at 20 kilowatts to add and subtract voltage through this buck-boost transformer. On the bottom here, you will see a big EMI RFI filter to make sure that high-frequency noise is not fed back to the line. And this is the output side. I think these are terminal blocks. You see under the wires, there's a terminal block. So you can strip some wires, input through. In case of single phase, you'll bring in 3 wires, hot, line 1, line 2, earth ground, input, line 1, line 2, earth ground, output. And then you cover it up with the cover, then do a strain relief on the cord, and you're done. It takes about 5 to 10 minutes to install and connect and turn it on. Very easy to use. And here you'll see the another board. This is the surge protection board, so that when lightning strikes, and in case we have to protect against lightning, this is the one that will fire, bring it, suppress most of the lightning energy into, and send it into the ground through this board. Here's the circuit breaker on-off switch. Combines both functions, on-off switch as well as circuit breaker. And then this is a hot air exhaust fan. So there's some vent holes here, so hot air. It's about 98% efficient. So that means if we were delivering 10 kilowatt load out of this box, we'll be producing about 200 watts of heat through this transformer and through the So then the hot air will be sent out and cooler air will be brought in from the other side. Okay, so that's what it looks like. A single phase machine. This is how it looks like on a three-phase voltage VRP. Basically, we put three of them in one box. You can see three buck boost transformers, three control boards, power boards, on a heat sink, two fans for redundancy, and these are the input surge protection board, as well as the EMI RFI filter. It's on this side, and wiring, where customers make the connection with their wires. Okay, I'll show you that portion on the next page. That's what it looks like. So when you open the cover of a three-phase VRP, you will see this will be facing you. On the left side, you'll see the two bottom holes. These are the cable wire entry holes. Bring in the wire here and make the connections. In case of three-phase voltage, you'll need to bring in 5 wires. Phase 1, 2, 3, neutral, and earth ground. You make the connections here, and then you bring in the wires from your load equipment. It could be computers, it could be a CNC machine or telecom rectifier and air conditioners, etc. You'll bring in the wires here and make the same 5-wire connections. Now, if your load is like a motor, three-phase motor, CNC machine, a lot of them don't use the neutral. So then you just don't have to use the neutral terminal block, or you don't have to bring out neutral wire to your three-phase equipment, which runs on delta input. Okay, so that's that. Next page. Okay, this is the key page on why we differ from everybody else, or all the technology. Voltage detection and correction time is less than 20 milliseconds, or less than 1 AC cycle. It's shown on the input versus output voltage waveform at right. This is the input voltage that just experienced a 20% voltage drop. After 2 seconds, voltage went back up. When this can happen, if somebody, your neighbor, or you have a huge machine that pulls hundreds and thousands of amps, maybe, get started, and transformer goes into some saturation mode, and you have a 20%, 30% voltage drop for a fraction of a second, maybe 1 second, something like that. So we simulated that kind of worst-case scenario, fast voltage change. And you can see, you can hardly see the 20 millisecond is buried in that two-second window here. So, but in another diagram, you will see a little 20% drop on that one cycle for 20 milliseconds. And then the next AC cycle, you will see the correct voltage that the VRP has worked to produce. In comparison, legacy voltage regulators, which use servo motor or tap change technology, can take half a second to 3 seconds to, which is 25 to 150 AC cycles, to detect and correct the output voltage. I'll show you a video of that after this page, comparing it side by side. Therefore, our voltage correction speed is 25 to 150 times faster than the servo motor and tap changer. This is, by the way, 99% or more of the voltage regulators found in Africa and Asia, one of these two types, servo motor or tap changer, because they're inexpensive, very low cost, built by millions and millions every year in China and India, etc. because they are low cost. A lot of people use this for residential applications, but it's not suitable for expensive mission critical equipment. Okay, I will go ahead and exit the full screen. Maybe for now, I'll end this particular show. And then go into, is everybody there? Can everybody hear me? Hello? Can somebody tell me that I'm doing okay?
Yes,
Hello?
ma'am, you're doing very great. We hear you.
Okay, good. You've been so silent. Of course,
yeah,
you know,
because
at the end of this presentation, I'll have at least 15, 20 minutes of questions and answers.
Yes.
So thank you for holding your questions. But okay, I'll go to the next 5-minute video. We test some servo AVR versus VRP side by side. So bear with me. Okay, let me go to that. Here's the video.
No, your sound is not up. The video sound is not up now.
Sound is not there?
Yes. You want to restart? You want to pull it back? Or we can play it from here. We got.
Well, okay.
Yeah. You want me to play the video?
What
from
I'll do is I will interject. Maybe the sound isn't going through. My sound is up. But, okay. So this is the Indian factory where the VRP is made. So you can see the same thing that I discussed. This is our factory in India. Tap change.
Hello, Nam.
Yeah, can you hear?
Okay.
Can you see?
Yeah. Let me play the video from here. Let me get a console to play the video, and you will see.
Oh, you want to display the video yourself?
Yes. So just watch it from your own
Okay,
end.
then
Yes.
let me stop sharing here.
Yeah. Stop sharing.
This is a demonstration of TSI static voltage regulator technology. As you are all aware, electronics is rapidly replacing electrical devices in factories, offices, malls, and residences, be it robotics, CNC, automation, and drives in factories, IT, HVAC, elevators, projection and lighting systems in offices and malls, sophisticated TV and sound systems, inverter air conditioners, inverter machines, LED lightings, and home automation systems in residences. The foremost demand of electronics is high quality of power, where any sudden voltage fluctuations, surges, sags are controlled within one waveform, that is 20 milliseconds or 1/50th part of a second. This is easier said than done by conventional technologies of servo voltage stabilizers or tap-changing transformers, because these may take anywhere from half second to several seconds depending on severity of voltage defect. The ideal solution is a static voltage regulator which has the capability to instantaneously correct all kinds of voltage defects, including the very harmful sags. Let us now witness a comparison of a typical servo voltage stabilizer with our TSI VRP static voltage regulator at a simple demonstration setup created in our factory at Vadodara in India. Here is a sag surge generator which supplies a nominal 230 volts to a static voltage regulator and also the same 230 volts to a servo voltage stabilizer. Both the servo voltage stabilizer as well as the static voltage regulator are designed to provide a stabilized output at 230 volts plus minus 1%. The sag surge generator can be switched on and off by this switch to generate either a sag of 20% magnitude or a surge of 20% magnitude. Accordingly, the input voltage to both the static voltage regulator as well as the servo voltage stabilizer will either suddenly fall by 20% or suddenly rise by 20%. To monitor the resultant performance, there is an oscilloscope with 3 channels. As you can see here, this yellow top channel records the voltage waveform generated by the sag surge generator. This channel is marked as input waveform to both the servo and the static voltage regulator. This waveform is then corrected by the static voltage regulator, whose output is recorded in this channel marked as VRP. This waveform is simultaneously also corrected by the servo voltage stabilizer, whose output is recorded in this channel marked as servo. We are now ready to observe a sag phenomenon. So, let's generate a short sag. As you can clearly see, a sag occurred on the input side of both the equipment, and both the equipment behaved very differently. The static voltage regulator corrected the sag within a single waveform of 20 milliseconds, but the servo voltage stabilizer took a very long time to correct. Furthermore, in the case of servo voltage stabilizer, as soon as the sag disappeared, servo stabilizer gave a high voltage output because it was still in its boost mode. If this output high voltage was beyond the cutoff limit, then servo voltage stabilizer would trip. But nothing of this sort happened in the case of static voltage regulator. You will observe from its waveform that it corrected everything within one waveform or within 20 milliseconds. Let's now observe a surge phenomenon. We will create a short duration surge of 20% magnitude and see the results. You can observe here, the topmost waveform is the input to the equipment, and this waveform clearly shows a surge. The second waveform is the output of the static voltage regulator, VRP, and you can observe the surge was corrected instantaneously. Whereas the third waveform is the output of the servo voltage stabilizer, where you will see that the surge was corrected slowly, and when the surge disappeared once again, the voltage was corrected back to its original value. So, as we can observe, the static voltage regulator would correct a surge or sag instantaneously, while servo voltage stabilizer would keep struggling. So, we conclude that the static voltage regulator is a complete power conditioner, which controls all kinds of voltage fluctuations, surges, and sags, all within 20 milliseconds, that is, one waveform. In addition, it also has a built-in noise control filter. This perfect technology is made available to you by TSI Power, based at Vadodara in India. For more queries or questions, you may write to us at info@tsipower.in or visit our website.
Thousands of VRP protecting gasoline dispensing, diesel dispensing pumps. Because with bad voltage coming in, these machines will lock up, which would be big bother, or get damaged. Textile spinning. India has a lot of textile industry. So knitting, weaving, textile, cloth making, etc. machines. Engineering process industry, for example, if you're making plastic bottles or food processing plant, you would need to protect all the expensive and important equipment from bad voltages. Wood cutting, CNC machines, motors can lock up and smoke when you try to run it with low voltage, high voltage. Those motors can be very expensive and time consuming to repair. Radar and communication equipment, R&D, testing, diagnostics, hospitals, CT machines, MRI machines, X-ray machines, laser surgery machines, etc. will all benefit from stable voltage. I mean, 100% safe voltage produced by the VRP. Plastic processing, already mentioned that. Printing and packaging. If you have a copier or printer or industrial grade printing shop, those machines are very, very sensitive to voltage fluctuations. You can get a wrong color to show up at the as a result. Because ink curing is a lot of times done by some UV light curing. And UV light intensity is very important to get the right color. Security and surveillance equipment, building management. In large buildings, you have building management systems that require stable and safe voltage. Okay, so those are there's really no application. I didn't mention like home air conditioners or lighting systems because they are not that expensive. Refrigerators, TVs, and most people just end up using $50 to $100 voltage regulator, which uses the old servo or tap changer technology, which we probably won't change for residences and small businesses. Okay, to the next page. Here are some user testimonials. Scientific Research Corporation supplies the U.S. Air Force, and they bought 16 VRPs, and they've been in use continuously for 2009 at U.S. Air Force facility. Who knows what they're doing there. But so for 16 years, they've been running, 16 of them have been running trouble-free. The equipment that they are protecting has also been very reliable and trouble-free, a real success story. I'll forward your email to several colleagues for their consideration. In USA and Canada, HP used about 100 VRP to protect their large format UV printers. In the USA, when voltage swung only about plus minus 10%, they were getting bad results. So they had no choice but to use VRP. They tried some other voltage regulators without any success. So they came to us and we supplied them. JPSA laser, about 50 VRP units for semiconductor micro machining equipment exported to China, Taiwan, and Korea during 5 years from 2007 to 2012. CEM using several hundred VRP to protect sensitive scientific instruments installed in USA and worldwide. We've supplied thousands of customers in USA over the last 24 years to protect all the equipment that are listed here against unstable voltages, surges, spikes, transient sags, swells, and high frequency noise, etc. Okay, in Asia and India, ESI in Malaysia used VRP since 2007. Ever since we started a factory in India, our sales in India has taken off, where we sell thousands and thousands of units every year now to Indian factories in various different industries listed below. Well, here's one that we'd be most interested in Africa. From 2003 to 2009, MTN Uganda used over 1,000 VRP, single-phase VRP units. I believe they're only 5 kilowatt VRPs to protect cellular base stations equipment from unstable voltages. They became, after by 2007 or 2008, they became the #1 brand of mobile phone in companies in Uganda. They had okay, so Uganda government forced them to sell, give about 30 competitors. So there'll be at least 3 competitors. I think there's Orange and maybe Vodafone or somebody else. Now 3 companies. Well, it could be Aircell.
Nam, can I interject a little bit there?
Happily, because it was so successful.
Hello, Nam.
Also, Uganda Telecom, Celltel, Uganda also used. Hello? Yes.
Yes, I just wanted to point out the testimonial from Uganda that I would have loved my answer here to confirm that. As at last year, when I saw the report from MTN, MTN Uganda still was rated #1 in network stability among the MTN networks in Africa. And it's good to point out the secret. The secret behind their continued stability is that investment in the VRP over 10 years ago. I just want to point out that. You may continue, sir.
Okay, thanks for that newer information. You are plugged into Africa a lot more than me, so thank you. V-Mobile and Celltel in Nigeria in 2006, 2007 installed about 100 3-phase 22.5 kilowatts. By this time, they were installing, here, they were not protecting air conditioners. And they only needed 5 kilowatts. And this was the first generation. Power requirement wasn't that high. But I think nowadays, a typical cell site might use about 20 to almost 30 kilowatt watts, because now you've got several air conditioners to cool the container, all the batteries that's in there. And about more than half this load is actually air conditioner loads in BTS, at BTS sites nowadays. Zain has in Ghana used 100 VRPs. 2007, 2008, MTN Cote d'Ivoire used 600 VRX. These are outdoor VRPs. And to protect their cellular base stations and air conditioning equipment at 600 BTS sites during those 2 years. And I believe this was also 3-phase, 30 kilowatt VRPs. Well, I will cover a few minutes to discuss our outdoor UPS products. We make single-phase input and output outdoor UPS uninterruptible power supply products. And with this type of performance, wide input range with 115 or 230 volt output, or wide input range plus minus, and then DC output. If in Africa voltage is so unstable, you may need something of this nature, because this works over plus minus like 12% range. The series less expensive, but the double conversion topology here gives you much wider operating input range and zero transfer double conversion UPS topology. Next page. Here's what typical line interactive XUPS. We sell a lot of these, thousands of these per year in the USA, Canada. Looks like inside. It's very easy to use. Ours, just open the door, hook up the wires, 3 on-off switches, and AC input on-off switches, and then the system on-off switch. Again, 10 to 15 minutes to hook up and start operating. Try to make it very user-friendly. Here's a double conversion outdoor DC UPS. You can see this is about 2,000 watt output. Very large batteries here. 230 volts comes in. Then we convert everything to DC, and then we convert it to either 24 volt DC or 48 volt DC. You can send out 48 volts, about 50 amps, 40 amps, about 2,000 watts of DC coming out with this outdoor DC UPS. Well, here's a typical installation. This is like a switch rack or equipment rack outdoors, installed at BP Refinery in USA. And they had it installed in 2011. We just got a repeat order for 5 or 6 more units just last year. So even after 14, 15 years, this is the UPS, that's our UPS right there. And this is BP's equipment. So this is a typical industrial harsh environment application. And this is our, this is my final page. Summarize the VRP precision voltage regulators from about 1.4 to 300 kilowatts. Next year, about this time next year, we expect to introduce new modular VRP with 300 amps and 600 amps. Eventually, in another couple of years, maybe 2027, we'll probably double that. So then, because these are like 300 amp modules that plug side by side and they operate in parallel, gives you N+1 redundancy as well as up to 4 times more output power. So at 1,200 amps, that would carry just about any large facility or any large equipment. If you can provide rock stable voltage with up to 1,200 amps of output power, like a 1,500 amp panel. Okay, Sparrowhawk, stack protector, large voltage regulator, but on 3-phase only, and these are not available. They're available only in the USA. And outdoor UPS products, we already mentioned that. ATS, compact automatic transfer switches. So that wraps up my presentation. So I'm going to stop sharing and let Tim take over.
Thank you, Nam. Thank you for your time. And do you have any questions from the online team yet? Anybody having something? Okay, good. All right, let me just put something here. Nam has told us, mentioned some of the companies that have been using this particular solution for many years. One thing you will pick from it is the reliability of the product we brought home. All right? We have a unit running in Iraq since Operation Desert Storm. It's still working. That's how crazy this equipment is. I know we are used to things blowing up and then you change something and then you buy a new one and then, but this is one investment that you can make and you'll be rest assured that you have the right thing to do. Please put me on the clock. Let me make sure people are not hungry. Let me make sure people are not hungry. In Tanzania, Lafarge, as part of the testimonies now in Africa, Lafarge, for those of you in Tanzania, somebody say hello over there. I see them. Can you put this? Let me see, Mr. Pamphili. Is anybody from Lafarge online? I'm not sure I see Pamphili. Okay, Lafarge Tanzania had a big power quality problem. They were having a shutdown, unexpected shutdown, and they couldn't explain that. They were busy spending money, buying transformers, and the thing continued. And Mantrac, thank God George is here, Mantrac Tanzania reached out and said, hey, we got a customer that has a problem. It's okay. And then they explained to me what the problem case was. I said, all right, we can solve that. They were like, come on, what do you mean? Is it not going to be easy? I said, yeah, it's a piece of cake. We'll solve that. So they engaged us with their special, what they call their special team in Switzerland, their expert team in Switzerland, okay? And they all look like Jim. The tall guys, light-skinned color guys like Jim, and then they see a young, small-eyed black guy coming to tell them we can solve problems, that are experts from ABB. They've told them, well, you got to get this container. So look, we'll solve the problem with our eyes closed. How would you do that? We show them this product, and then the next product we show them this one, which we'll be discussing on the other side of the presentation when Jim comes up. And after all said and done, the gentleman in Switzerland gave the go. We installed in Tanzania, I think the engineer that installed it is online. Can you put a zoom? Let me make sure we're having confirmation so that nobody will say we are saying things that don't work. Put a zoom. Engineer Alfred, do I have you online? Can you open up and say hello? Is Alfred online from Tanzania? Should I speak Swahili? Kaka, uko wapi? I can't hear him. I can't hear him. So the reason I'm bringing out this testimony is just to bring it home.
Sorry, you muted my microphone.
Oh, okay, you're open now. Now we're discussing Lafarge.
I was having some troubles to unmute it.
Okay, great. Alfred is sitting in Dar es Salaam in Tanzania.
There's also before Mr. Nampag get out from this presentation, there's I think question from Tanzania in the chat. Then I would like rather to him for checking that question and respond to it.
Okay, we're going to get into NAM's Q&A, and then we'll pick up those questions real quick. I just want us to discuss in 1 minute the Lafarge case that finally you installed, and take 1 minute to talk about that real quick. How we solved that problem in the Kim feed in the cement plant.
Yeah, of course. The first approach that we did, I went for a site survey that I did in cooperation with the engineers from Lafarge. Thereafter, after doing the survey, then we gave them the proposal on how we can mitigate the problem that they were having at that time. And what we did, we installed Santama SPD and VRP in the clean field, and those all areas that they were having some challenges. Thereafter, installing the VRP and SPD Santama, they were starting taking the records of the issue that they were having, the challenges before installation and after installation. And thereafter, I guess it was like after 6 months, they came up with the evidence. I think you have it, maybe you can share whatsoever, that what they noted before and after, it was a huge change of the power protection that we did. That's what happened in Tanzania, the Lafarge cement factory.
All right, thank you very much for that witness. I dare say from the report that they sent to us, they had about almost 87% uptime. You can imagine if you're producing such, if you cost such a change for any production company, 80%, 87% uptime. It simply means you've also chopped your maintenance cost almost absolutely zero. You can take your maintenance budget and put it back into OPEX, into CAPEX, and you'll be fine. Now that happened in Lafarge. Pamphili is a plant manager for Lafarge, about 3 plants. He told me it was going to be online, but it's okay. Maybe he's just caught up in something. I brought that testimony because that is home, that is Africa. All right? I talked about the reliability of the solution, how long these things have stayed. From other testimonies from Uganda, from Cote d'Ivoire, and back in Nigeria. All right, let's get back to NAM. I understand there are questions from Tanzania online. Can we get to Q&A real quick? And then if anybody has any question here, any situation that you are aware of in your processing plants, in your data center, in the banking or telecom, whatever experience, and you've been trying some solutions and you feel something is not really happening right, you can bring it up. That's why it's called the Power Quality Conference, and let's see what we can do about that. Okay? So think about your life situations. We're going to deal with that. Thank you. All right, let's get into Q&A for the VRP session. Do you see the question they posted on the chat? All right, Alfred, let me let you read the question on the chat from Tanzania. Go ahead. Read out the question so now I can take it.
Yes, I was muted. Hello, can you hear me?
Yeah, I can hear you. Go ahead, read out.
Yes, I was muted, I think, with the admin. I think somebody called RX is asking, would like to know, how do your high-performance protection systems integrate with hybrid power setup involving the AC, commercial grid, solar PV, and diesel generator?
Okay, Nam, can you hear me? Did you mute Nam? Can you make sure Nam is open? Nam is muted.
Oh, okay. Now I'm unmuted. Thank you. Yes, I understand that hybrid power system is very, very popular, especially in telecom applications, but nowadays more becoming mainstream because now you have 3 AC sources available to you. The utility AC, but many times you have several hours of power outage every week sometimes. And during that time, you would have solar panels with huge, large battery banks. With nowadays, the battery cost with lithium iron phosphate batteries have come down, and size and weight has come down dramatically. So it's very, very, sometimes it's cheaper to produce electricity with solar power than regular electricity. So you have that, maybe 8 hours of battery autonomy if you have huge batteries, or maybe 2 hours of battery autonomy if you don't want huge batteries. Then finally, you might have a backup generator, diesel generator, as a final backup in case power does not return after 2 or 8 hours, and then you run out of battery and it's cloudy and raining, so you don't have any sun anymore. It's at nighttime, something like that. Then you would the backup generator would turn on automatically when battery goes into low battery condition. And important thing is that you want to still bring all that 3 sources of AC of various quality. Generator voltage may swing up and down by plus minus 10%. Probably the inverter voltage from the battery inverter is probably stable, plus minus 2 or 3% only, and good sine wave. Utility could be plus minus 15, plus minus 20%, as we've seen in the video. So after all the transfer switches, you want to put the VRP just before your equipment. Typically, we recommend that the VRP be placed within 3 or 4 meters of the AC panel that's feeding the critical load or the piece of equipment that you want to protect, because you want to protect, regulate, and improve the quality of all 3 types of AC power that's coming in. They go through automatic transfer switches, and then it comes into the VRP input, and then VRP output is that safe, constant voltage that equipment loves to operate on. I hope that I answered your question. Hello?
Yes, ma'am. Alfred, can you check? I'm confident the person that
that
asked.
was the question raised by Mr. Alex, is not me.
Okay.
I was reading. on it. I guess Mr. Alex, if he has any other question, then he will raise it up. Although there's somebody coming, Mr. Case, maybe Mr. Nam can go ahead with that question as well.
Another question?
It is saying, apart from OCP and OVP, what other protections can be provided by a VRP?
Okay, VRP provides against over voltage. It could be constant over voltage for hours or days of up to about 25 and sometimes up to 30% over voltage. So instead of 230 volt coming in, if you have 290 volt coming in, VRP will still bring it down, so you get about 240 volts coming out of the VRP. And same thing with under voltage situation. If voltage is very low, let's say 170 volts or 180 volts instead of 230 volts for hours or several days, will continue to operate to give you that 20% boost and get probably close to 220 volt AC, even with minus 30% low voltage, only get minus 10%, which is still good voltage for equipment. Plus, all these transient voltage fluctuations, you saw on the video how voltage could change up and down quickly, and most people don't see it, and they put a voltage regulator, old style servo AVR or tap change, and equipment is still having problems shutting down or getting damaged. People are scratching their heads. How come we have a surge MOV, surge protector, and then a servo AVR, tap changer AVR, and there's still problem. Maybe it fixes 80% of the time. Problem is solved, but that 10 to 20% of the time, maybe once a month, is still a big trouble. So that's what we protect against. And then we also mentioned that input surge protection is built in, plus EMI RFI filtering, so high frequency noise is blocked from, doesn't go through, and the voltage sag and swells and sags are momentary over under voltage situations. So it pretty much covers all except one, if there's a power outage. There's, VRP is not going to give you continuous power when there's a real power outage. A voltage drops to 160 volts, then we consider it to be unusable voltage, and we cut off and we shut down. So then, you will need a UPS with batteries for that, but that's a very expensive proposition to use large batteries and large UPS. So the only problem that we do not fix is an actual power outage that goes for several seconds or several hours. It's something you need a real UPS for that. Okay?
Thank you very much.
Thanks, Nam. Just in any case, if there's any further question, then they can raise up their hands. Thank you very much.
You're welcome.
Thank you. Now, just be on standby. Can we just take a few more minutes to look at what we talked about? How are we going to really put the revenue back in the pockets of the users of VRP? In terms of what we experience in Africa with the cost of diesel, if we can stabilize the power that is available within the hours that the government makes it available, and by the way, we already know that utility power is the cheapest source of power in any country. So businesses run better on power supply by the government. That's the cheapest source of power. The reason it's so expensive in a place like Nigeria is because companies are generating the power for themselves and they're producing. So it's tough to invest if you cannot have the financial muscle to generate your own power. And then also the challenge of many companies getting out of the grid, because the power quality is too poor, it can't sustain production. Can you pull up the Excel sheet? Put the Excel sheet on. Judging from the experience we had in Pactive now this is the USA here, because power quality problem is all over the world. The only difference is availability. In the US, you have power available. And it will shock you. There are some parts of the US that don't have power. I know somebody will like, what are you talking about? We have customers that call, they don't have power. I mean, no greed. No greed. So Pactive is a company that produces packaging. They have about 160 plants in the US. They produce foils, McDonald's cups, and other stuff. But they've suffered a lot of power outage, power problems in many factories, and they've tried different things. When they got in touch with NAM, and NAM called me up, I stepped into it, and we were able to find the problem. So I started an example to say, hey, we are not the only ones suffering the power quality problem. It's not like it's just peculiar to Africa, all right? Now, Nigeria has about 30% power availability, or they used to have. I understand some places now they can get up to 10 hours of power, 12 hours of power in a day, which is beautiful. And I'm glad George is here. And you know how much it costs for 1 liter of diesel. Almost everybody here runs diesel. This hotel, I'm sure they're running on diesel. So now, as we discussed some time ago when we were cracking our brain, we said the generator in a percentage load, is that where we at? That's the capacity, right? That's the first point in the Excel? Okay, good. So we are saying, no, don't go for that. Come back this way. Come to me. This just in 2 minutes will be out of this one. So we try to benchmark this thing, not just to like crack our brains to say, hey, is this real life? And we found it's real life. And if it's not, I have somebody from Mantrack here that will tell us we are wrong. So we said this is generator percentage load, diesel consumption in liters. And this is the generator capacity in kVAs. And we say this is 25% load per hour, 50% load per hour, to 75% load per hour, and full load, if there's anything like full load. Okay? That is like above 75%. The generator doesn't really have a lot of space. So a regular cell site for MTN or for the tower cores, the access link, probably will be around 30 kVA, if I'm right. About 30 kVA, 20 kVA, okay. So we say, okay, if he's running on 25%, let's say you just have only one radio in that site, what's the diesel consumption per liter? You staying under 1 liter per hour, about that. And if it's running half, you're doing about 3. If it's 75, you're doing about 4 liters per hour. If it's running on full load, above 75, you're doing about 5 liters per hour. And then we say, okay, what is the cost of that? At 25, that is, if it's on 25% load, 20 kVA, you are doing about 98 cents, approximately $1. $1 per hour on 25% of load. If we scale it up to 75% of load on 20 kVA, we are talking about almost $4. That's the consumption of the generator. Now, George is here, and I'm glad he's here. He's from Mantrack. That's a very seasoned engineer right there. So, if this is way off from your experience, you can point it out. We can approximate it and see what we're spending. So, can we move a little bit for me? Move the slide. Come on. Yeah, keep coming. Keep coming. Keep coming. So we are on the 20 kVA. We say, okay, for telecom sites on access links on 20 kVA, if you do 25% load on 1,000 sites, that's what you're looking at to spend. if you are doing $52,940 per hour, this is 1,000 sites right now, consumption. And if you are on full load, you are about $5,000 per hour. I'm very confident if you check your operations, this cost is near accurate. So we said, if this is per hour, come for me. Are we at the end of the slide? Okay, it's okay. So full day, full load cost per year for 20 kVA, remember we were here, for 1,000 sites, at 25% full day, full load cost. That is, we are dealing with about $8 million for 1,000 sites. Nigeria has about 30%, averagely, 30% power availability. I mean, I'm talking about Nigeria, this is statistics. Tanzania has about almost 70% power availability. I'm not talking about power quality. So if we say out of 24 hours, we have 7 hours of power. Now, they may come in randomly. We can have 1 hour in the morning, 2 in the afternoon, 2 at night, but generally, your systems are running on those power. You need them for a cell site kind of a place. If we can clean up that power, maximize it, we will chop off that cost and put it back in your pocket. And you are talking about $11 million back in your pocket. Now, if somebody is running a 250 kVA, can you go down, go back this way? If somebody's running a 250 kVA generator for your site or for a big building, Lambert Electronic is here, and they are wonderful people, building some beautiful stuff, build refineries, build high-rise buildings. So you are dealing with about something in between here. If you scroll it down, you will find out how much we're going to save. Because the consumption of this gentleman per hour on 25 is already 19 liters per hour. That is 280 kVA generator is about 19 to 20 liters per hour consumption. Multiply that by the cost of the diesel, that's what it's going to give us on this Excel. We will share this document to all the people that register so you can use it to check where you're going to fall. Our goal, therefore, is what NAM has explained regarding the VRP. The VRP having pulse width modulation technology, buck boost, okay, IGBT switched, which is fastest, 8 milliseconds switching. You wouldn't notice when the input is fluctuating. So it means at every point in time, the output is stable, your machines are getting the right voltage. What you also do is your cost or your bill itself will be static. If you are supposed to pay Disco in Nigeria 10 naira per hour, it will stick to 10 naira per hour. How? Because you are not drawing more power. Because when voltage goes low, current goes high, your bill goes high. But if voltage stays stable, current stays stable, bill stays stable. Now, I understand those in Enugu, this was one of your questions. Enugu, this was one of your questions. I just touched on it. We'll take on it again when we have the time. The voltage is stabilized by the VRP, guaranteed. It means your bill will remain stable, guaranteed. All right. So,
Sorry, Tim.
yes, sir.
Sorry for interruption. Maybe there's 2 questions here again, maybe from Mr. Nam before it takes off.
Go ahead.
Can I go ahead?
Yes.
Okay, thanks. First question is from Mr. Rex. He's asking, do you support real-time monitoring and remote diagnostics for power quality? What protocols do you use, e.g., SNMP or else? That's the first question. Should I go with the second question or one by one?
Yeah, go ahead.
Go ahead.
The second question too.
Okay, thanks, sir. Second question is from Mr. Case. He's asking, what about reverse polarity protection? Can a VRP prevent damage if the input or output polarity is accidentally reversed? Thank you.
Okay. In terms of remote monitoring or diagnostics, we do not have it incorporated into the VRP yet because we just believe in just maximum reliability as being our design philosophy. Just we don't expect VRP to go bad unless lightning strikes it and output goes to zero. And then you will know your equipment is down and you'll get some report that you're not getting power output from the VRP. As far as input voltage going up and down, that's part of my job. Our job is just keep output voltage constant, even if input is plus minus 30%, which is, wider than anything else in the market. And we've had good, it does have three indicators, LED indicators. Green, good, working, okay. Yellow means it's on bypass mode. There's an overload situation or some fault condition. Then there's a red LED, which means VRP failed. So if you have somebody on site, you can check those LEDs once a week or something like that. But another reason that we didn't want to give you all these diagnostic things extra is that there are some less expensive remote power quality monitoring devices that you can purchase from other companies. Hundreds of companies make these type of over voltage, under voltage alarms, and they send it to you via SNMP and other, protocol. And a lot of sites I know already employ that kind of power quality monitoring and reporting system. And sometimes I say, VRP is not an analog device. It's a more digital device. Because we run on onesies and zeros. If the microprocessor stops issuing onesies and zeros, we just go dead. Output, it becomes zero. And that may happen on a normal, once every 10 years, VRP may fail. You might have to do some repair. But with that kind of a frequency, if you don't get a weekly or monthly report of trouble, it just is useless in a way. To monitor something that will never happen for 5 or 10 years, why even bother monitoring the device when it's just like a piece of rock? You might, when will the rock break and crack in half? Every 500 years or something, people don't do that. So that's, and then there's less expensive, already well-established power quality analyzers and remote monitoring diagnostic equipment, et cetera, that's been in the marketplace. And I got involved so much. What was the second question?
The second question was saying, what about reverse polarity protection? Can a VRP prevent damage if the input or output polarity is accidentally reversed?
Okay, you must mean, AC polarity can only mean you have neutral and phase reversal, because we don't have plus, not like DC. The AC mode is, you get phase 1, 2, 3, and then neutral and earth ground. I mean, if you mix reverse neutral, the earth ground, and hook it up to phase, you got big problems. Sparks will fly. So you want to make sure your earth ground is real earth ground. You don't mix that wire. Neutral should be also very, very sacred on a three-phase system. Having the correct neutral, we depend on having the correct neutral input. Because as you saw on the presentation, there are 3 different independent voltage regulators VRP is working simultaneously. Each one works between neutral to phase. So
So now it's asking, can you
don't need VRP because again, the solar inverters are digital devices. They will typically produce 230 volts or they'll produce 0. They don't give you swings of plus minus 10, plus minus 15% swing because they don't have to. They got it.
Do you have solution for quality as related to harmonics distortion? Okay. And the second one is, what are the parameters that are required from you for you to be able to provide a solution for me? So I have a site that is having a power quality issue, especially probably data centers, and what are the parameters that you will require so that I can help and step into it.
Thank you very much, Judge. Now, this question is about harmonics, and I know we're going to be dealing with harmonics by John Michel down the line and Jim. So, concerning the parameters that we require for us to be able to support you, definitely from site surveyor, we can capture for ourselves the exact situation of the network, and then we can provide a solution. It's going to tell us the voltage situation, it's going to tell us the dips, the sag, basic power quality requirements. For the harmonics, of course, we're going to be able to see. Now, this is very key, because the next session after the launch, we're going to be dealing with this whole area of power quality. I'm going to have Jim will be speaking about the SPDs, and then John Michel is somebody that you want to hear, okay? We're going to be talking about the instrumentation and everything power quality. I mean, we're going to shake the bottom pot right after the launch. Please stay put. All right, let me take quickly the introduction from Enugu, if they can get them. I know they're itching to say hello to Lagos. Can we get Enugu quickly before we head out? And please confirm that launch will be ready in a few minutes. We have Enugu. Any other question from the room? Somebody had an experience. They built a telecom site somewhere in Abuja. I don't know if Benson is online. Benson, are you online? Can you put a zoom on the screen, please? Let's see if Benson is online. Enugu is up. Okay, Enugu is up. Can we hear their voice? We're not hearing you, Enugu. You are muted. Unmute Enugu. I see it is muted. Enugu is muted. I'm not hearing them. Somebody watching from the YouTube, can you tell Enugu to unmute?
Question is about the adaptability of this technology. Just to ask if, first of all, it will be accepted within the governance system of Enugu and Nigeria, and secondly, whether it will interfere with the already existing infrastructure that may cause some legal issues. Thank you.
All right, I know this is Enugu, right? The question from Enugu? Okay. I know we missed the introduction. I'm sure that we have this in already within Nigeria from long time ago, before we decided to go to Chinese. There is no regulatory interference with the electrical standard of Nigeria, okay? Actually, when we get to deal with the SPDs, which we have some samples here, we do make sure that the color codes also align with the color code of the country. And that goes to say that these things are not off-the-shelf kind of products. They are produced per country, per demand. You don't buy them from Walmart. You don't buy them from any 100 kilowatts. That's 1.6 mega. Okay? They have double servo. Good company. Good thing for big buildings. Some of you may have them here. And you have a need for power quality. Let me give you a situation with a customer in Tanzania. I would have loved to mention the name, but let me keep it quiet yet. They have a data center running on OTIA. And OTIA, they lost 4 UPSs. You know, you can imagine that. This is like a bank. And then for 2 days, bank is out. Customers are frustrated. Employees are frustrated. Some people are on the chopping blocks to be fired. And then somehow they reached out, and Alfred got in touch with me, and I said, okay, what do they have? Okay, they have OTIA. Leave it. Don't do anything to it. It's working, right? Yeah, but they still have problem. We will help the OTIA to leave. So, recommendation, we're going to put sign timer to the OTIA to protect the OTIA from the surges that are giving it some headaches. However, for the bank, to deal with this kind of voltage that's going to be happening so fast, hey, we're going to knock in VRP and see their network, 1, 2, 3, and we're going to go like laser surgeons. We don't have to give them 1.6 mega of VRP. You can't pay for that. It's too expensive. So we're going to go straight to where the problem is. Like laser surgeons, they go to the brain, they solve the problem, the hand starts moving instead of cutting the whole hand. Okay? Simple recommendation. And that's it. You can't go beyond that. So when you talk about compatibility, we will work with what you have existing. However, we know what the problem is. We can improve what you have by clearing up the power quality, making it not to perform. Your UPS are blowing up, your battery is no longer performing to the length of time it's supposed to do, like we have in Tanzania, NMB Bank. We'll be able to support you with Saintama. And just before I move away from that, this thing I just said now, I have somebody, I think somebody from Tanzania, Isaac from NMB Bank, I think I saw him online. Can you put a Zoom? Can you go back to Zoom? Let me see if Isaac is here. NMB Bank Tanzania. He's our major customer in Tanzania. Okay? The biggest bank in Tanzania. With almost 500 branches or so. More than that. Can we put a Zoom on the screen? Let's make sure. Let's take this quickly and then we go for it. Please confirm lunch is ready. Do we have the Zoom? Alfred, if you can hear me, can you book Isaac to open up and see if he can say something?
Yeah, let me check with him. But I see him, he's online.
Okay. Okay, as soon as he comes online, let me know. I was talking about a site in Abuja, if Benson is here.
No, he's connected, but he's muted. Maybe you have to unmute him.
Unmute him, please. Unmute Isaac. What name does he have on the screen? Isaac Chimbi.
Isaac.
Yeah, Isaac.
Yes. And also tell PA is to be fine-tuned. The voice is not that much clear.
Okay.
Okay.
Is Isaac up?
Not yet. Still muted.
Unmute him, please. So in Abuja, they built a telecom site, 80 kilowatts, and it's supposed to be solar site. After building that, Benson is online, I think he's online. He reached out to me. There was no power. I mean, there was NEPA, but the voltage was too low to charge the site. As we speak, it's a current problem. You've invested 80 kilowatts, built a cell site, but you don't have power. The only option you have is to take a generator to that site to charge. But that's not the goal. What our solution would do is, no matter how bad the NEPA is, we can go as low as 50%. We'll have what we call VRP plus. NEPA brings the voltage as low as that site will start working right away for the next 30 years. So that's the kind of problem we solve. All right, let's take it from Isaac. Is he there? Okay, we'll use him, we'll get his testimony when we deal with the sign timer after. All right, if there's no more questions, is there?
Hi, Tim.
Hi, Isaac. Good.
Mr. Isaac is connected.
Great, good afternoon.
Yes, Tim, how are you?
Let me speak in Swahili.
Good afternoon. Sorry, I was a bit.
I know. Nzuri sana.
Yes.
Habari za kazi.
You have.
Now they've sold me to East Africa.
Hongera kwa presentation.
Asante sana.
Yes, sorry, I was off the laptop. Maybe you can pardon a bit so that I can
No
grasp
problem.
what was ongoing.
All right, let's take you on for just for the next few seconds. You know, you've been using Saintama, I mean, you've engaged us for the past 10 years. We've been working with NMB for the past 10 years. Our classic situation was the mezzanine UPS was knocked out, batteries knocked out. And we came in, the generator was also having a big spurious problem. And we installed Saintama unit in the controller of the generator first and did in the ATS, and then went up to the mezzanine panel, and the problem was completely solved. They never had to service that generator apart from oil change for the next 4 years. The gentleman from Mantrac can give you the contact. Anybody can verify. So, Isaac, what is the experience of NMB Bank so far with what we provide? And why is it that you guys have chosen not to use any other product apart from beginning from Saintema? And I know now we're talking about the VRP, but the whole world, I mean, audience is listening to you to hear why do you invest so much in power quality?
Thank you so much, Tim. My name is Isaac Nchembi from Tanzania, and I'm currently working with the NMB at the Power Specialist. As you had highlighted that till 2025, we have been in 10 years operating and using the Saintema surge protective device for our branches and data centers. Just to highlight the history, at first we were facing a challenge of lightning strikes, and our devices were being impacted, especially the network devices. This gave a rise that we needed a protection for it. Through these years, I won't give specific evidences, but just to highlight, successful later impacts also from the power lines. We face challenges that sometimes there's no lightning, there's no lane, but we find that the devices have been impacted by surges. So we had to widen our view that if the scientists of the... Hello?
We can hear you.
Yes.
Yes, yeah. If Saintema managed to save the problem on lightning strikes and lightning surges, we to share this testimony that the device is working, and I'm not sure if this is just a privilege to our company, but we have been enjoying a 7-year warranty on these Saintema devices. But the worst thing is that the devices are not getting destroyed. So it's a 7 years warranty, but we're not getting from it. I think that's all which I can share on the Saintema. But as you know, whenever you are getting something good from somewhere, when you face another problem, you will invite them also to give their view. Currently, we are having a problem of low voltage to most of our sites, because we have some sites which are very remote, and most of the transformers are being overloaded. But also we have a problem of the voltage fluctuations. Previously, we have been using transformers to solve the problem. For instance, maybe we open a branch at a certain remote area. When we faced the low voltage issue, we normally contacted the utility company. They would come and make a survey, investigate, and most of the time the finding was there's an issue of low voltage and due to overloading of the transformer. And they would give us a quotation and suggest to us to install a dedicated transformer to the site. We did this. We were installing these transformers to resolve this low voltage issue, but unfortunately, because after installing the transformer, still the transformer is under maintenance or control or ownership of the utility company. So unexpectedly, you find they still install other customers to the same transformer, and the issue gets back to disturb and interrupt our operations. So when I had contact with Tim, we discussed about this, and he proposed the VRP voltage regulator. After investigating on it also through the through the network, and I was impressed with what I was informed. So I got into contact with my management and tried to explain to them what VRP can offer and what it can resolve from the cases we are facing as challenges.